Hello, my name is Peter Mark Bearward. I'm a solutions architect for Google Cloud Platform. And I've been at Google for about 3 years. And about 3 years before that, I also worked for AWS. So I often get asked by customers, what are the big differences between the two platforms? And so I thought it'd be good to walk through what those are in a webinar format so that a lot of people can figure out what the high-level differences are and kind of hear about where we see where the two platforms lie. One thing that I'd like to say up front, though, is that this webinar is just going to focus on the compute platforms. I think we could probably spend hours talking about each broad subset of categories between data and databases and so on. So we're going to just keep focused on compute today. So what I'd like to walk through just briefly is tell you what we're going to do. I'm going to talk a little bit about what is the high-level difference between the platforms, and then walk through each of the subsections of what constitutes a compute platform. So infrastructure as a service, essentially core compute, managed virtual machines, and then platform as a service, the different platforms there, containers as a service, so managed container services, and then finally taking a look at serverless functions and seeing how they compare. And so this talk is geared towards a particular audience, and what I think is an ideal audience for this. So if you have some experience with AWS, if you've deployed applications there, if you've taken classes, if you know about the platform there and aren't familiar with GCP, but you're curious about what GCP is, how it works, how is it similar, how is it dissimilar, I think this is going to be really helpful for you. Also, this is going to be a somewhat technical talk. We are going to talk about the details about how to deploy applications, how to use particular services. So it is definitely geared towards a technical audience. And then finally, I think if you're somebody who is planning on deploying an application or has already deployed applications to the cloud, I think this will be very useful to you. What we're not going to cover, though, aside from sticking to core compute, like I said earlier, we're not really going to touch on the storage services, even the ones that are part of, say, the compute services. Networking often goes hand in hand with compute, but again, I'm not going to touch on it too much simply because of time. I think we could probably spend hours and hours on almost any of these topics, so I'm going to try to keep it just to compute. Also, while this is a technical talk, I'm not going to go into minute detail on, say, differences between APIs or command lines, libraries, and so on. I'm going to mention them briefly, but we're not going to go into fine detail there. And then finally, I'm going to try to keep this as opinion-free as possible. I'd like to present you with the facts of how the two platforms are different, rather than my opinion about what's better or worse. In many cases, Amazon and Google have simply made different design choices about how certain things are implemented. And they're neither better or worse, they're just different choices. But they are important to call out so that if you're developing applications that would run on one or the other, that you know what is the difference and what you need to account for in order to deploy those applications successfully. So let's go through what a high-level overview is between the two platforms. So I'm going to start with a few definitions, and I'll start each section with a set of definitions, just so that if you're familiar with AWS and their terminology, that you can see how it maps to Google Cloud Platform. And in many cases, you're going to see a lot of similarities. In some cases, there are going to be differences. But in this particular case, for the platform overview, you can see it's relatively similar. Collections of data centers are called regions in both cases. An abstracted data center, which is one or potentially more buildings in reality, is an availability zone on AWS, and it's just a zone on GCP. And there is edge caching that exists beyond the regional footprint, these POPs, these points of presence that are for CloudFront on AWS and for multiple services, including CDN for Google Cloud Platform. So if we look at the global footprint for AWS, you can see a pretty even spread across most continents except Africa. The non-filled in circles are regions that have been announced but have not been opened yet. And if we look at a similar map for GCP, you see a similar spread across most continents except Africa again, and a number of announced regions that have not yet opened. What you can see from this is There's obviously more AWS regions than GCP ones, but that they both have a relatively decent global spread. And if you need to reach customers in almost anywhere in the world, again, except Africa, there's likely a region that's nearby. And so if we actually look at the numbers, you can see that there are currently 16 AWS regions. 6 have been announced. There are 12 GCP regions, and 5 have been announced. 44 availability zones on AWS and 36 availability zones on GCP. So there's clearly a number difference there, but in terms of latency, in terms of deployment, there's likely something nearby most of your customers. In terms of the edge locations, in terms of the POPs, the numbers are pretty close. AWS has a little shy of 100, GCP has a little over 100, so there's a lot of global caching for fronted material by CDN. Now, finally, I think this last point is probably the most important in terms of actually deploying applications on AWS versus GCP, and it's about the global network. So when you create a network within AWS, you're creating a network within that region. So if you deploy in US East or Asia West or wherever you are, it's going to be a network that is just within that region. And if you would like to connect that network to a network that you still own, but that's in a different region, you have to do some sort of connectivity, whether it's a VPN or you front your application with APIs or whatever method you choose to do. On GCP, the networks are global in nature. This is not an option, it's just how they exist. So if you create a network that you own in your GCP project, it is going to be a global network. And so if you wish to deploy resources, say in US East or Europe West or wherever you like, you can do that and you say, yes, this is going to live in US East, but it's going to live in that network that you have created. And so any other resources in that network that are in different regions are going to be on that same network, unless, of course, you decide to create different networks. And there's, of course, network segmentation. You can do subnets, firewalls, and so on. But it is a fundamental difference between the way the two platforms work that is very important to know going in before you create applications. So just to touch on what services are inherently global versus things that exist within regions, the two that are in common are CDN and DNS, which makes sense. Those are, by their nature, global services. And in both cases, CloudFront and Cloud CDN for CDN and Route 53 and Cloud DNS are both global services. So they don't really exist within a single region. There is a slight difference between GCP and AWS in terms of two other global services. Cloud PubSub is a messaging fan-in, fan-out service that exists globally. It's not within a region. AWS has messaging services like SNS, SQS, but those are deployed within a region. So it's important to be aware of that if you're using those services and looking at the GCP equivalent. And also, if you wish to front your application with an API front end, there's API endpoint, beg your pardon, cloud endpoints on GCP, which also exist globally. Meanwhile, at AWS, that is a regional service, API gateway. So now let's walk through infrastructure as a service. So managed virtual machines, essentially. And in many cases, this is where customers focus most of their time and effort in terms of deploying applications, in terms of using the cloud. This is actually where most of, say, the bread and butter happens in terms of using the cloud. This is where a lot of the focus is. And so I'm going to be spending more of my time on this than, say, the other sections, because there is a lot here and a lot to cover. So, like I said, we're going to start with a list of definitions so you can see what's similar and what's not. In this case, we have got several differences in terminology, but I'd like to point out, if you're familiar with AWS, that this is mostly just terminology differences. In terms of core managed virtual machines, there's a lot of similarity in terms of how you actually use it. So different service names, obviously. I'll be referring to them as EC2 and GCE going forward. Virtual machines are relatively similar. We're calling them instances. Amazon has Amazon Machine Images. Google Cloud just calls them images. And then a number of very similar services that have dissimilar names. So managed firewalls, scaling, locally attached disk, network attached disk, all exist. So those concepts, if you're familiar with them on AWS, work just fine on GCE. but they are called different things. So instead of EBS, there's persistent disk, or PD. Instead of ephemeral disks, there's local SSD. Instead of autoscaling, there's the compute engine autoscaler. Instead of security groups, firewall rules. And I'm going to be talking a little bit more about these temporary virtual machines, because there are more subtle differences between spot instances and preemptible VMs. So let's look through what the similarities are. So if you've deployed something on EC2, what matches up on GCE? How does that compare? Is that going to be totally different or not? And the answer is it's actually relatively similar conceptually. If you've done a lot of this work before, that should map pretty well to what you're doing if you would like to do it on GCE. So you create instances from stored images, you launch those images whenever you want, you terminate them whenever you want, and when they're running, you have total control over them. You have root access on Linux, you have administrator access on Windows, and it's entirely in your hands. There's nobody coming in managing that for you. In terms of virtual machines. These are your machines while they're running. You can tag them, you can run pretty much any version of Linux, most versions of Windows Server. There's a lot of flexibility there, and that's similar across both platforms. And so if we look into what are the differences between the images as you use them and store them and use this as a repository for operating systems. I think that the first point is actually a very important difference. On AWS, you store your images either on S3, so instant store images, or they're EBS-backed images. And so you have that choice about where they are stored. On GCE, they are stored within the compute engine service itself, rather than within, say, block storage. The other difference that I think is important to call out is that images are global in nature on AWS. I beg your pardon, on GCE rather than on AWS where they're regional. So on AWS, if you make an image, it is for a particular region, and if you would like to share that within your account, you can do that, but that is an active step you need to take. On GCP, these images are globally by default. So if you create an image for your company, that's going to be global, and you can use that in any region. I think the next point is also something important to call out. While both platforms have images maintained by creators and vendors, so Canonical for Ubuntu, Windows for Microsoft, AWS allows anyone to make an image public, and you have these community images that are available to any user to be able to launch. GCP does not have a concept of making an image public. So if you can create as many images as you like for your own firm, for your account, for whatever you like, but you cannot make them public when you create them. So that's an important difference. And if you look at the vendors that do maintain images, I think we have mostly similar vendors. So like I said, Microsoft, Canonical, Red Hat, a number of other ones are very much in common, and you'll see a lot of those images when you try to create an image or try to create an instance on GCE. The one important one to call out that is missing is Oracle. So you can create Oracle Enterprise Linux on EC2, but you cannot on GCE. And the OS support, again, you can run most versions of Linux on both platforms, most versions of Windows Server on both platforms. AWS, you can use Windows Server 2003, which you cannot on GCE. And so if we look through the types of instances that both platforms have, there's also a lot of similarities. So if you want to run an instance with a shared core, so you're not guaranteed full access to that compute power at all times, say for test instances, for minor workloads, for bursty workloads, you have that option, these shared core families. Standard core families, which have a relatively even balance of compute and storage and RAM, exists on both platforms for kind of middle-of-the-road workloads or where you're not really sure what you need to specialize in. And then finally, the two types of families where instead of balanced memory and RAM, you have more tilted towards RAM, and then in the other case, more tilted towards CPU. And so if you look at where the families are not similar, you'll see a couple of design choices where this is what I talked about earlier, where there's simply different design choices by the different platforms. So AWS has chosen to assign a particular family to have GPUs. Meanwhile, on GCE, you actually attach GPUs to the instances that you choose to. So if you're familiar with the, say, G family of instances, and I believe the current number is G3. I put in X's simply because AWS does update their family numbers. I suppose it's almost versioning. But generally speaking, the G family is the GPU attached. The P family on AWS is for general GPU computing. If you're using those and you would like to see something similar on GCE, you're not going to see that immediately, and that's because you can attach GPUs to the instances when you create them. And similarly for SSD storage, so the I family on AWS, on EC2, beg your pardon, has attached SSD. On GCE, you would simply attach SSD disks to whatever instance you launch, and so that's how you would get that equivalent service. So I think what's important to point out is the bottom two, though. EC2 offers a dense storage family of instance types, and these come with a lot of hard disk attached to them, in the multiple of terabytes, I believe. And in GCE, there's just simply no equivalent to that. So that's important to call out. And then finally, on GCE, you can actually create your own instance type. So you basically say, well, I need this much RAM and this much compute, and I'm going to create an instance type that doesn't exist currently. It's not part of a standard family, and that's actually fine. You can go ahead and do that, and that's something that's not available on EC2. So I mentioned earlier how both platforms have the concept of temporary instances, and these are instances that are going to cost you a lot less than regular instance types, but have the possibility that they could be taken away from you at essentially a moment's notice. And they're really actually, as strange as that may be to hear, if you've never used it before, they're actually really good at using for burst workloads where you're going to need some extra compute power and you kind of don't care where it comes from or how long it lasts. Analytics workloads use these a lot, again, for similar reasons. So if you've got anything that's tolerant of having, say, lots and lots of workers, and some of them aren't going to always be there, then these are great use cases for that. But they work in essentially fundamentally different ways on the two different platforms. On AWS, you're bidding on unused capacity in EC2. And so if, let's say, there's an instance type that costs $1 an hour, you could bid, I'm going to pay a penny per hour. And if nobody outbids that, then you can use that instance as long as you want until your bid is outbid. And so if somebody comes along and says, I'll pay 2 cents an hour, then they're going to go and get that, and it will be taken away from you. On GCE, these instances are actually at a fixed cost per instance type. And if you create a custom instance type, it's fixed based on the number of CPUs and RAM that you use. So essentially the resources that you're using. And this means that there's more predictability in terms of what you use, but there is not that option to be able to go very, very low. So there's, again, pluses and minuses to the design choices that each one made. The other important thing to call out is that GCE preemptible instances will exist as long as GCE does not need those resources or 24 hours. And that is a hard limit. And so if your use case lasts longer than 24 hours, you're going to need to get some more preemptible virtual machines and hope that they last for the time that you need. On EC2, they will last as long as EC2 does not need that resource. Or you don't get outbid. So it's potentially a lot longer, but it could also be, you could get that resource taken back from you at almost any moment. One other important thing to call out, if you need to use a premium OS, so something like Windows or Red Hat, you can't do that with spot instances, but you can do that with preemptible VMs on GCE. And then finally, both services do give you some warning. If you need to shut down what's happening on that particular instance while it's running, you can do that. The difference is slight. 2 minutes versus 30 seconds, but you do get that warning time on both platforms. And finally, walking through what the purchasing and billing is like for these two platforms. Honestly, I could probably spend an entire webinar just on how to do different purchasing options on the two platforms. It can get complex. There are lots of different options. Again, this is because most customers spend a lot of their time and effort on virtual machines, core compute as I call it. And so there are a lot of different ways to kind of meet those expectations and meet those choices that customers are making. If you're just launching instances, you want to do whatever you want with them. This is what we call on-demand billing. This actually very, very recently changed. The last couple of weeks, both platforms went down to per second billing with a 1 minute minimum. And so you'll see hourly rates on the websites to find out how much these cost, but you're actually billed by the second. The small difference here on EC2, if it's a premium OS, so again, something with a license included, something like Red Hat or Windows, those are still hourly costs. Now, here's an important difference between the two platforms. One of the things where GCE has something that EC2 doesn't, that you should be aware of, is this concept of a sustained use discount. And so this is a discount that's applied to your bill the longer you run your instances per month. And it's something that's applied automatically. It's nothing that a customer needs to do. But the longer you run your instance, you could get up to a 30% discount on the actual hourly rate at the end of the month. Now, both platforms have options to be able to purchase discounts at a longer term rate. On EC2, they're called reserved instances, or RIs. On GCE, we call them committed use discounts. These are available for both 1 or 3 year commitments. And that's actually kind of where the similarities end in terms of these purchasing options. On AWS, you purchase, there are 3 different purchasing options. There's standard, there's convertible, and there's scheduled. So standard, you pay some amount of money up front. The more you pay up front, the bigger the discount. And you have some flexibility to move those instance purchases around between that family. Convertible, you have more flexibility, but a less discount. And scheduled, it's very much what it sounds like. You need to schedule when you need a reservation of a certain amount of instances. And so the key difference here is that on AWS, you're actually purchasing instance reservations of a certain instance type, which is why there's that flexibility needed between, say, a convertible RI to be able to move between either instance families or zones. On GCE, you're actually purchasing a certain amount of resources. You say, I need this many cores, I need this amount of RAM, and that is actually what the committed use discount is. And so there's more flexibility, because honestly, we don't look at how many instances you're running. We're just looking at the number of resources that you're consuming. And so that's an important difference to look at if you're planning out how to bill and pay for virtual machines. So now we're going to move on to platforms as a service. This is a service, if you're unfamiliar, where you can write an application, you ball it up in kind of whatever is appropriate for that particular programming language, and then you submit it to the platform that is going to manage all the compute resources and all the networking and so on for you. So you don't have to kind of consider that, you don't have to look at that, you just let it go. And so both platforms offer these. On AWS, this is called Elastic Beanstalk. On GCP, this is Google App Engine. Probably just going to call it App Engine. And there are 2 versions of App Engine that I'm going to walk into or explain in just a moment. But you can see here that they all support a number of different languages, if you're used to them. Beanstalk and App Engine Flex both support custom runtime, so that if you want something that's not on that list, you can add things. All of them auto-scale fairly easily, and networking-wise, you can place them within your VPC if it's a Beanstalk or App Engine Flex, and I'll go into why App Engine Standard does not do that right now. So the difference between App Engine Standard and App Engine Flex, App Engine Standard has been around for a long time. It's actually one of the very first cloud services that Google launched. App Engine Flex has come along relatively recently. And the difference really is that App Engine Flex is managing your application on virtual machines in GCE. Meanwhile, App Engine Standard is actually deployed on Google infrastructure and not on virtual machines. And so it's a bit more of a black box. And there are some trade-offs there. App Engine Standard is a lot easier to scale kind of at a moment's notice because we're not creating new virtual machines when we need to scale in response to demand. Meanwhile, Flex has more, as the name implies, flexibility in terms of what runtimes you can use for it. You have access to those virtual machines. You can log in. You can have root access to those machines. So you have more access to your application, but it comes with a trade-off. So this means that Flex, App Engine Flex, actually operates in a similar manner to Elastic Beanstalk. Beanstalk is also deployed on virtual machines. You can have a lot of flexibility in terms of what you want to run. You can have custom runtimes if you wish. And so it's very similar to both of them. And then in terms of what all three platforms have in common is that you're just writing an application, deploying it. You can connect to pretty much any cloud service you want. There's no real restrictions there. You can configure environments, can configure different versions. You can do upgrades, A/B testing, and so on. And so that's one of the versatilities of having a PaaS platform, is that you have all this flexibility managed by the platform provider rather than having to do a lot of that work yourself. So both of these platforms, Beanstalk and Flex, support custom runtimes. You can essentially do whatever you want. The only thing that you need to be aware of is when you're doing that for Beanstalk, you're actually modifying the OS image. So you're modifying the AMI. On App Engine Flex, you're actually submitting a Docker file. So you have there's a different level of flexibility in terms of that, in terms of where that flexibility comes in. One other thing that I think a lot of companies use PaaS platforms for, or PaaS services, I should say, for, is scaling. Is that you're letting the other, the platform provider deal with scaling. And so you don't have to deal with responses to scaling, you just have to set up your application appropriately. In both cases, they respond to triggers. You can tell the application, I want to scale right now, so a manual-based trigger. And one other difference is that Beanstalk will trigger based on a certain time. So if you know that this is coming in advance, you can set that up, and that's not available on App Engine. And the way they're priced is relatively straightforward. Beanstalk charges you for the resources that you use as part of the service, so EC2, EBS, and so on. On GCP, you're charged for, there's certain instance classes that are essentially buckets of consumed resources on App Engine Standard. And on App Engine Flex, it's similar to Beanstalk, where it's only charging you for the resources that you're consuming. So now I'd like to walk through managed containers. This is a more subtle difference. On GCP, we have a service called GKE, even though it's Google Container Service. It's more of a call out to what it's managing. It's actually managing Kubernetes, which is an open source container management service. Written by Google, we open sourced it, but GKE is essentially managed Kubernetes. On AWS, there is ECS, which is EC2 Container Service, and that is also a container service written by AWS, so that's something that they managed and controlled on their own, but is not open source. And so in terms of actually using them, there are a number of similarities in terms of managing groups of containers, in terms of deploying them and so on, with different nomenclature. I think the key difference here is, for anyone who is familiar with running containers, is that if you're familiar with Kubernetes, if you've run Kubernetes in a data center, if you've run it on AWS even, that GKE is simply managed Kubernetes, and that there is a lot of not just similarity there, it is the same platform. And so I think what's important to note if you're running containers, that there are a number of things built into Kubernetes that you can be familiar with that are not running on ECS. So things like DNS for service discovery is built into Kubernetes. For AWS, you'd have to use a third party like Consul. The scheduler is, again, built into both. And if you want to have some scripting, if you want to have some automation, it's really kind of dependent on user scripting within AWS. Meanwhile, some of that's already built into Kubernetes. So these are kind of things that are important to be aware of if you're running a lot of containers in the cloud. In terms of billing, like Beanstalk before that, it's only the used resources for AWS. On GCP, it's the used resources, plus there is an hourly charge for the overall management of that cluster. And then finally, I'd like to talk a little bit about functions as a service. So if you're not familiar, these are functions that you can trigger based on events that happen and otherwise don't consume any resources while they're not being used. And these are relatively new. AWS Lambda or Amazon Lambda has been out for a couple of years, Google Cloud Functions for a little bit less time. And they're very interesting in terms of kind of new workloads that people are finding ways that they want to trigger compute resources but don't have them running all the time. So if you want to respond to events, if you want to do data processing that maybe isn't happening constantly, isn't a constant stream, there are actually really good use cases for using functions. But it's very early days, I think, for serverless functions, but they're becoming much more popular. And if you look at the differences, there are certainly some differences between how many you can have running at the same time, how many or what volume of data you can deploy, and language support, but the concepts are very similar. I think what's important to note is the differences between what can trigger. So there are a number of different triggers. This slide might be a bit difficult to read very quickly, but these are available in the documentation for both services because the triggers are really very important, because this is how you're going to use functions between the different platforms. So I think they're worth looking into. Both platforms support them, and they're something it could be interesting to add to a running cloud infrastructure. If you're looking for any additional resources in terms of the comparison between the two platforms, there is some documentation on the GCP website. So cloud.google.com/docs/compare/AWS. There's a lot more detail about both the compute platforms and other things like storage, big data, messaging. There's a lot of comparison there between the two platforms. So if you're curious about a deeper dive into some of the things I've mentioned here, that's a great place to start. Thank you very much. I hope this was informative, and we'll be back in just a few minutes to take some Q&A. Thank you. Hi, so we're back with a few questions, and so I'm going to read through these just in order and talk about kind of what I think about these answers. So the first question, I want to treat my infrastructure as code, and I will be using both AWS and GCP. I'm concerned about learning both CloudFormation and Deployment Manager and the operational overhead involved. What strategy would you suggest? That's actually a really good question. So the first thing I'm going to say is if you're unfamiliar with CloudFormation and Deployment Manager, these are services offered by AWS and GCP respectively that are ways of describing infrastructure as code. And so you have essentially a templating mechanism for both of those, that you could relaunch environments, you can describe how these environments are supposed to be set up, you can pass in variables to make different environments. And so conceptually, they work the same way. In implementation, there are certainly some differences. And so these are ways of managing your infrastructure. They're not by any means required, but they are both options on both platforms. And if you would like to, say, manage two clouds, I can see this being a problem. You see there are two different services. They have different language support. Obviously, you would have to implement them differently. Is there a way to avoid that overhead? Basically, yes. There are third-party open source options. I think the most popular is Terraform. It's used quite a bit by a lot of customers because it lets you manage resources not just on clouds, on multiple clouds, but also within data centers. And so if you have resources in a data center, if you have resources in a cloud, and you would like to avoid double work of having one configuration language here and another one there, Terraform is a great way to manage multiple resources across data centers and across clouds. It has great support for AWS and GCP. Next question. If I have running VMs on EC2, is there a way to bring them over on GCE? So yes, again, this is reliant on third party. So there are a number of partners that we work with that will actually either install agents or scan your AWS running infrastructure, obviously with you giving them permission, and actually copy them over to GCE. So one that I've worked with in the past, CloudEndure, has an agent that will do this. You can watch it transfers extremely well. CloudEndure has a partnership with us, with AWS, and I've seen that work pretty well in the past. There are others very similar to those, so there are a lot of options out there to be able to do that. Third, can I use Beanstalk and App Engine tools to run containers? Yes, I probably skimmed over this when I was talking about the platforms as a service, but both Elastic Beanstalk and App Engine Flex support containers, support custom containers, so you can essentially do whatever you want with them. You can deploy them wherever you want, or however you want, whatever kind of container you want. Interestingly, App Engine standard actually is deployed on containers in Google infrastructure, but it is not a container that you can modify. Next, if I want to run distributed workloads using Kubernetes, is it okay to use GKE on GCP and Kubernetes on AWS? Can I manage both centrally? Yes, actually, that's a really interesting question. It's something that comes up a lot because we do see Kubernetes being deployed in a lot of different places, from AWS to data centers to obviously GCE itself, rather than using GKE. An interesting design pattern that we've seen lately in these multi-cloud, multi-region deployments is using GKE as a common GKE and Kubernetes as a common way to deploy infrastructure across possibly very disparate types of platforms. And what you can do, there are some design patterns that we've got on our website about having, say, DNS centrally located, load balancing centrally located, but actually distributing traffic to multiple clouds where you have GKE on GCP and Kubernetes, say, on AWS on EC2. And that works. That's great for developers because they're developing to a common platform. They're developing to containers on GKE. In terms of actually managing it centrally, actually that is not an option currently. You would have to create separate pods on GKE and in Kubernetes on EC2. But the advantage of that is that really what you want to do is actually build that management into your development pipeline, so further along from production management. So if you build that into your CI/CD tools, it's not really a matter of where do I manage Kubernetes, it's where am I deploying, and then deploying is simply a matter of picking a pod, and that actually ends up being much easier to manage than trying to find a way to centrally manage a bunch of different Kubernetes pods. Last question here. Is there a conversion training course to help me with learning GCP coming from an AWS background? This is a great question because it actually leads into our final slide. Yes, there is a number of courses offered by our training organization where they are specifically geared towards people who have an AWS background, so they have a skill set with using the cloud, deploying applications on the cloud on AWS, and have that background and would like to learn more about GCP. We do have actually training courses specifically geared towards people like that, and being able to take that knowledge that you already have and applying it back to GCP if you want to start learning about using GCP, if you have to deploy applications there, multi-cloud, switching clouds, whatever the case is. We do actually have those resources, and it's actually my very last slide. So if you want to look at more training options on GCP, those are options for you. And again, there's GCP for AWS professionals, plus a lot more training courses where you can deep dive into all sorts of things, from compute to big data to machine learning, if you wish. So I hope this was informative. I hope you enjoyed the content. Again, please look at some more resources that we have on our website, and thank you very much.